Hello, my name's Michele, Guel, and I'm a newbie. So do they define gap as like 20 years in code, not coding? But that's okay. I started as a coder at 19. It's probably been since 1988 since I coded. Many of you probably were not even born then, but it's all good, right? Talking about the voice of experience. So today what I want to talk to you about is my passion is around information security. It's a field I've been in for since 1988. Again, many of you probably weren't born there, but it's an exciting field. And I heard someone say, what does it have to do with the, I'm not even sure what that other topic was, so I have to sit around and learn what didactic, whatever that is. So that's how far I'm at. So our journey tonight is we're going to look at what the landscape is out there. What are the transformational changes that are happening that affect our world, that provide us opportunities to do unique and exciting things, right? I mean, how many, well, I was thinking about how could I do a cool intro. I was in on the East Coast and I was traveling last week and I thought, well, it'd be really cool if I had time. I could go home and I could get my Fortran deck of cards and ask them if they knew what that was. But anyway, how many people were at the She's Geeky thing at Moffett Field this past weekend? Anyone? All right, a couple folks. I didn't even know that conference existed. I've been told that some of the infrastructure I worked on at NASA Ames is now in that museum. I don't know how that makes me feel. And they're actually trying to get, someone emailed me and he says, you never believe what I found. I get email from folks at NASA Ames every now and then. I found your report on the aftermath of the Morse worm experiment. Do any of you even know about the Morse worm? Okay, a couple of you. So they want to submit it to go in that museum. Now, I don't know how I feel about that. I mean, I am 50 and I'm fabulous and I'm excited about life, so I think that's okay. I can be alive and I can go to the museum and see something I did. I think that's pretty cool. But we're about here, what's happening today? What are the exciting things and how can y'all participate? I'm from the South. How can you all participate and help making a secure infrastructure, a secure world, because we're all connected, right? Everybody's got their phone, probably a lot of Androids, who knows, a lot of iPhones, their iPads, their tablets, their Macs, whatever. So what are some of the transformational changes that are changing our life that impact the security posture of Google, of Cisco, of San Francisco, of the world, of the United States, of the nation, that what's happened, right? Mobility. Probably a lot of you can't remember before when there wasn't cell phones, but how many remember when you didn't have a cell phone? All right, a couple of you. All right, some of you younger, well, okay, I'm not saying like when you were in kindergarten you didn't have a cell phone. I'm saying where there weren't no cell phones to have, okay? When 300 Bob was exciting, you finally had remote access. Okay, but now we have mobility. We can be connected anywhere, anytime, and do just about anything. But there's a lot of dangers out there. Identity theft, you know, clickjacking, all these click here on Facebook and bam, something bad happens, right? Cloud, everything is a service, right? Smart connected everything. The smart vehicles, you know, pretty soon it's not going to be too far off that, you know, the smart spaceship pulls up to the office and it doesn't have to connect in, right? It connects to the wireless. It downloads all the photos, automatically uploads to Facebook, right? And everything else. We're getting there. So what does that mean in terms of what we have to do? What does that mean in terms of the security posture on what's going out there? Any security geeks in here? I mean, that's what you do for a living? All right, a couple of you. May the force be with you, as well as the code. Okay, this is a quote. And actually, the Cisco year-end security report was just published yesterday, and I actually found it this morning. Modern threats are capable of infecting mass audiences silently, effectively, not discriminating by industry, business, size, country, gender, location, anything else. So the 100+ people we have sitting in here, it's probably fair game that at least 10 to 20 of you are being infected somehow, somewhere on one of your mobile devices. Or your organization's being hacked into, have already been hacked into. We have to think about security all the time. The parameters have changed, so our approach has to change how we look at developing applications. So this is about coding and developing, right? You're being handed a list of requirements, a design doc, and says, create this for me. The project implementation team's expecting you to create a good, secure product with no vulnerabilities. Does that happen often? I don't know. Right, so the perspectives have changed. There's a gap in perception versus reality of really what the impact is of security, not only in your household, in your organization, and in the world. Stuff happens every day, right? Technology metamorphoses. So in the span of my technical career of 30 years, astounding when you think about what's happening now, what they can do on the little bitty chips, you know, the astounding technology. The connectedness and how much we can get done, how faster, how empowered. I mean, kids grow up connected. My 2-year-old grandson, I have 10 grandchildren, do the math, right? He knows how to navigate on his mommy's smartphone to play his favorite little learning games on ABCs, right? You grow up connected. Architecture has changed. It's no longer about rack space and iron in a data center and running out. It's about virtualization, right? We got to be faster, connected. The capabilities have to be tightly aligned. No longer this interdependency. You do your thing, I do my thing. If they meet up in the middle, well, it's kind of okay. We have to change the way we do business, right? The threats have changed. It used to be a single, you know, you would get a virus. It used to be individuals for capture the flag. It used to be, I want to get your data. It used to be, I want to get your identity. Now we have hacktivism for a cause. We have nation-state threats of what people are trying to do to take down whole infrastructures. 9/11, smart grid. Think about when your smart vehicle that drives itself. Do you want a virus that's going to take you off the road and spin out? No, I don't think so. You want to think about the connectedness, right? It's not about getting your data now. It's about breaking into your organization to break into someone else's organization. They want to get into Google so they can get Google's customers' information and break into there. They want to get into Cisco so they can get BP information and break into there. The game has changed, and so must we in our approach about how we think about security architecture. Did I skip one? No. I'm just standing still, but I'm working on it, right? But many of the challenges remain in building it in. My passion is around building it in. It's around building the next generation, mentoring and bringing the next generation of people who are going to think from a security architecture's perspective, do security architecture reviews, live and breathe security, because security is not an event. It's how we have to live our lives today in the connected world. All of us need to think about it. Right? There is a shortage of technical talent in the security field. I was at a user meeting yesterday in Southern California of 18 big companies. We're talking Fortune 500, Fortune 50 even companies, Fortune 100. Every single one of them has open recs for some sort of security position. They can't fill them. There's not the talent out there, which means the ones in the field are going to be in high demand, right? It's about ownership. Well, someone else is dealing with security. I'm just designing the code. I was given a design document. I'm coding whatever it is I need to code. I'm going to build it. I'm going to test it. Someone else is going to worry about security. Not all levels of the management structure think about security and own it what they need to do. We all have to own security. There's not a good understanding or a consistent understanding about what the risks and vulnerabilities are. If you think about day-to-day, everything you do from when you get up, constantly Facebooking, tweeting, searching, purchasing, your flight ticket, you name it. Everything's connected now. Pretty soon you can, you'll be Facebooking on your microwave front, while you're waiting for your coffee to boil in the morning, because that's where, that's where your interface is, right? The vulnerabilities abound, right? Security, people aren't following secure development lifecycle processes. They're not following secure coding standards. They're not doing input validation all the time, consistently, right? And the intruders, the hackers, whatever you want to call them, the bad guys, they're ahead of us. They've been ahead of us from day one. They're very well connected on the back. They share information. There's whole networks. There's tools. They build tools. And so it's constantly running in front of them to keep up on the game. What can we do? As soon as we make a tweak, they make a tweak. I was reading some articles today. New malware, actually, they're calling it Frankenstein, because it goes out and it takes code snippets from other applications and builds a code that looks benign, but it's learning behavior. It's metamorphosizing, if I said that right. There's things that are happening, right? Project teams aren't unaware of all the gates they have to pass. At Cisco, we have a very standard governance process with the right governance gates that project teams are supposed to go through. Sometimes they go around the gates, they go over the gates, they didn't know the gates were there, it was invisible, and they go live. Anyone have this? It's actually on the support. 2 days before go live, oh, I need an ACL change. What are you doing? No, we can't do that. Right? And then they have to go back to square one. So the result is stuff happens. This is just from today. Don't try to read the headline. You could go out and find stuff. I could have spent all day and got you tons of articles. This is just in a few minutes. Stuff happens because security is not built in. We have to build it in. And what we have to do is that security must reside in the DNA of everything, right? Projects, programs, services, infrastructure, process, and lifestyle. A mindset. Everybody needs to own it because you can all do your part in securing the infrastructure and adding value to your organization to do your job in writing secure code or testing code for all the test cases. We can do it. It's got to be part of the DNA. Develop a passion around it and think about it. If you look about what the information or security architecture space is, you will not find a consistent definition. This is just pulled from some job postings. I was going to try to pull one up because in my mailbox I probably have about 3 or 4 or 5 or 6 people asking, because now security architecture is a buzzword. 3 years ago, when I started an industry body of work around codifying the architecture practice, it was too early before its time. Right? We're out there, we're trying to get people, it was too early, but when we took the time to explain to people, they're like, we need that. Now you hear the buzz. Everybody's talking about security architecture, but there's not a common definition yet. Right? You'll see lots of different blueprints. Well, what is security architecture? What are the pieces of it? And these are just a few. It's an end-to-end. It's a holistic approach that we have to look at. You can find any number of things. But there's a lot of misconceptions around what security architects do or what is security architecture. Just to name a few, it's always someone else's responsibility. The internal network's secure. I don't have to worry about doing any security in my application, right? The security architecture review process is just those information security, they wave their magic wand and somehow the solution, which often the teams come to us, it's a black box, is secure. We don't, it's, trust me, we coded it to the design standard. We did everything we were supposed to. You might have done that, but what about third-party products? What about the misuse cases that you never thought about the code in there, right? Or they think that these security architects are these weird beings that speak this interesting language that others can only understand with a decoder ring. Everybody else here says, wah, 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 blah, blah, blah. Not true, right? We're just human beings. Or the security architecture reviews the checkbox. We don't have to worry about that until we're ready to go live. We just kind of go by the office. They give us a rubber stamp. They give us all the ACLs we need or JVMs. Everything, we're good. Not true, right? Or it's done at the end of the project. It's holistic. It's got to be done throughout. The reality is, we can never think that it's somebody else's job. Wherever you're at, whether you're writing the business requirements document, you're doing the design document, you're in the build phase, you're in the test phase, you're in the test and integration, or the release phase, there's something that you should be thinking about from a security perspective. Maybe you're a product manager. Maybe you're trying to add new capabilities. What are the implications of that new capability? Is it the best thing to do to connect A to B? Sometimes, I still do, I don't do consulting anymore on projects in Cisco. Here's a case in point about what's the next best thing to do. Worked on a project that had very high sensitivity level of information. So we had a lot of security requirements put forth and what they had to do with the architecture. It was, went into the design document, went to engineering and the project implementation team. They did a lot of good security controls. They made that tight. They did everything. They built a big firewall, not a firewall, but they did all the right security controls. Encryption, access control, multiple gates, all that sort of stuff to protect the data because it was very sensitive. So much so that we were told, if this gets out, you're all fired. Very strict, right? 6 months later, they come back, oh, phase 2 is we want to report on it. And now we need the data to reside in the reporting database, which wasn't designed for highly sensitive information. So there's where a new capability may not be able to be secure, right? So you probably read the rest of these. The last one I like, evangelize, evangelize, evangelize. I sometimes feel more like an evangelist about information security architecture than a distinguished IT engineer, which is my official title at Cisco, or senior security architect. It's about getting it out there, helping people understand what the security ramifications are. I don't expect managers, directors, vice presidents, senior vice presidents to understand all the security implications of a particular project or feature, product code. That's the responsibility of the people in charge of security architecture, security engineering, security development. To understand what that threat landscape is, what the attack surface is for their particular thing that they're building. What is an architect? Here's the Webster definition: one that designs and supervises the construction of large buildings and structures. One that plans and devises. So in my history of working at Cisco, I've been there for eons. So as I said, 11 years at NASA Research Center, where I did coding, software support, software testing, on debugging, including the Cray. Like everybody, once something remembers more, I remember you debugged SynMil on the Cray. I'm like, I did? How did I ever find the bug like that? So I remember. So, but now at Cisco, in terms of what does it take to do security architecture, this is my view. It's more like a symphony conductor. You got to pull a lot of stuff together. You got to understand the big picture. Doesn't mean that I need to know how to play the trombone and the flute and the bass and the triangle and everything else, but I need to know when to pull it in. I need to know when the sound's different, what I need to do, who I need to connect. I need to know the basics of the note and how to direct the overall thing to pull it together for something that sounds fabulous, is secure, and does what it's supposed to do. Now, is this a popular thing? I don't know. It may be. I go out and I read, we need an information security architect. Well, back there, well, one who's going to do policy, you know, that's part of it. You know, one who's going to ensure compliance, that's part of it, but that's not what it is. It's a buzzword. A lot of skill sets are needed in addition to just the hardcore security skills, right? Got to know how to do an architecture review, what's involved in there, what's in terms of the assessment, building requirements. You need to align with the business. It's all about enabling the business. So for so long, and even today, many organizations, security is an inhibitor. I mean, how many folks, just be honest, how many feel like security is an inhibitor to your day? Why do I have to have a 12-character password? Isn't there something easier? Why do they make me do, you know, the screen lock after 5 minutes? I'm tired of typing in my password, right? Oh man, why is my badge always the one that, you know, the smart certificate on it that I have to log into? Why do they want the security questions? Does anyone feel like security is easy to do? That's actually part of the problem, right? It's not easy yet. We were in a meeting yesterday at this offsite I was talking about, and one of the guys, and we're along there with them, right? I won't tell you what company he's from, but he says, you know, we have a goal by 2016 to totally get rid of clear text passwords in the infrastructure. And everybody's like laughing. And again, these are like big companies. Big company. You would all recognize all the names. And I'm like, well, we're up there with them because it's too hard. Right? If we tell you you have to have 12 characters and we're going to change them every 60 days or 30 days, you all got this long list or post-it notes, or you got, you know, text files on your iPad, your tablet, whatever that says passwords, and you can't remember. Or, you know, if you're my age, you have so many accounts all over the internet you can't remember. There has to be a better solution architected in there. If we have to go through so many gates to do it right, they're going to find a way to burrow under, burrow around. Right, so all this sort of stuff. Big thing here, mentoring and developing. There's a shortage of talent. It's about evangelizing what's important about security architecture to get the bugs. Yeah, I think that's kind of cool. Maybe I'll do that. There's opportunities. And if you're a code junkie, which is totally cool, you have an opportunity to do the right thing. Write the code right. Validate your input. Follow secure coding standards. Learn more about the field. You know, learn what you can do. You know, don't be so gregarious on verbose error message that tell exactly what they need to do. Right? Don't put in those hidden features that the customers will never find. The backdoor password. Right? We don't want to do that. You can have vulnerable code that allows attacks past well-secured infrastructure, or you can have kick-butt. We're filming, so I can't see the other. Kick-butt code with no vulnerabilities, but you can have insecure infrastructure. Net is compromise will happen. So our jobs is to minimize the impact. When your code fails, you want to fail gracefully. You don't want to fail open state. Well, you can do anything. The door's wide open. Oops, I didn't expect that. Right? How many people, oops? How many people have big oops? Be honest. How many people coded a big oops? Come on. Nobody wants to raise their hand. Anyone in your young careers, there's some young bucks in here. If you did something like really stupid and you were really embarrassed and you really tried to clean it up before anyone knew? A few. My biggest oops, well, actually I have two. At NASA Ames, my biggest oops, because I was a system admin at one point, was doing the ARM ** in the wrong directory. But it was like 7 in the morning, so I was able to reload the operating system and get everything back before they came in. My biggest oops at Cisco when I was managing the firewalls in the 90s was to put the statement in the wrong thing and closed off the traffic. But you know, that was the early days. It wasn't as big as it was now. So we all have oops, right? Coding has issues. It's hard to secure something 100%. There's a lot you have to do. And why don't people do it? It takes time. Well, that's a lot of different test cases. Oh, I don't want to write those verbose comments. Who reads the comments anyway? Do I really have to check for the buffers? Do I have to make sure they entered the right amount of data? Do I actually have to check that it's within the bounds? That takes a lot of time. But now there's actually tools, right? You get fuzzing tools, you got all this other cool stuff that will do it for you. But there's still something to be said about static code analysis, peer review, sharing ideas. You show me my stuff, I'll show you yours, to find out a new way to do stuff, right? How can we hack? Well, I thought that's all in there, hacking the Android devices. That's got to be a lot of fun. On the Cisco report, I'm not capping on Android, but on the Cisco report, it showed it was like 2,200 and something % increase in Android malware in the last year. That just speaks to the popularity of the Android devices, right? At Cisco, when they allowed to get Macs, and Mac was going to be a self-supported platform, everybody was going to the Macs because the Windows suck, right? Everybody's like, I don't want no PC, that sucks. Anyway, we don't have to have antivirus, we don't have to have we don't have to have all that security stuff and IT stuff that slows us down. But I would say, well, wait till there's enough Macs out there and you'll have Mac malware too. It's not that it's insecure, it's about how many people are using it to really to exercise all those, it's a feature. Okay, there's a lot of places where stuff can go wrong. I actually like to use this picture because I don't know where I found it, but I'm like, to me that describes IT infrastructure. What was there first? Was the house there and the tree grew up? Or was the tree there and they built the house there? When did the power pole come into effect? And look at the dude on the ladder, he's got sandals on. Okay? That does not meet OSHA guidelines. So this picture perfectly describes the security challenges because when you get a lot of stuff working together, stuff happens. Well, I can't say that, but stuff happens, right? You may have kick-butt code. I keep wanting to say the other, but I don't want to get in trouble. You can have kick-butt code, but what happens if you're calling a third-party software and they have ducky code and you can't get them to patch it? Well, guess what? Your kick-butt code is ducky code now, all right? So you can have architecture misses and gaps. One of I'm being filmed, so I have to be careful about Cisco stuff. But this happens. I'm reviewing a project and we told that, right? So later on it comes about where they were supposed to develop this report and it was going to go into the blob in the Oracle database and there was going to be this automatic process to pull it out of the blob and send it over to here. And then I guess in the build phase, the builders, they couldn't figure out how to make that happen, so they decided on the FTP option. Oh, well, we found a server over here and it was just really easy to FTP and then they could pick up from here. I'm like, what? That wasn't the design specs. Coding errors abound, right? We're all here, we all make coding mistakes that abound. Data governance issue, it's all about the data. They're not trying to break into for your personal stuff, yeah. I want to know, I don't know, Kevin's password so I can identity theft Kevin, right? Or maybe so I can find his stuff to get to the lady next door. It's all about what can we get with the data. Yeah, they had it's on the, I'm not gonna say, there's probably a few Cisco folks in here, but when we log on to our internal webpage, they occasionally have these little, what do you call it, polls. So the poll was, what most concerns you about personal data? And there was like 5 questions. Passwords, health information, social media, and something else. And I'm like, passwords, of course, because then that's the keys to the kingdom, they can get everything else. And I was happy. 47% of the people chose passwords, so I already answered that one. It's all about the data, broken processes, all these things. You probably read all the points. Third-party products. Huge, huge ramification about using open source products, third-party products, because you don't control those. You need to use them because it's more efficient to use them, but you don't control them, right? And I'm sure not all organizations, Cisco does, I'm sure Google does, and other big companies here, they have governance in place. If you're using third-party products, an open source, you have to register it, you have to know what version, so when there's an issue with that, it needs to get fixed. Because you could code till your eyes turn blue and you do every check you can think of, and then you got bit in the butt by the third party. And you don't want to be the writer of the third-party package that kicks and bites someone else in the butt. Okay? So we all want to think about this. There's a lot of stuff out there. So when you think about doing security controls and evaluating, don't try to look at the diagram, it's just for example purposes only, right? It says that in the small print somewhere. When you think about, well, if I'm looking at a implementation, what are all the things that I want to consider, right? Normally what happens is people go, well, security, we just tell you what it is and you do check. We come in, we wave our, this is their perception. We're ready, we've coded it, we want you to sign off, we tell you, and we're trying to find out what it is. We said, no, it's good. It's the black box. Just kind of wave your wand and call it secure. That doesn't happen. In reality, what we have to do is, what's all included? How many network boundaries are we crossing? How many databases are we connecting? What is the application space? How many servers? What are the protocols that are we doing? How are we doing identity management? How are we doing authorization? Do we need to do encryption, right? What's at here? Looking across it, right? And we want to add controls. It's all about knowing what the attack surface is for your thing, whether it's a single program, it's a mobile app, no matter how cool it is, understanding what the attack surface is, and your job is to reduce that attack surface, right? And our job, as a security architect, knowing the threat landscape, if I'm looking at the attack surface of everything together, where do I need to put the security controls? Is it just encryption? Do I want to make sure that it's a tiered architecture, so the application interface is in with the database interface, right? What do I all need to do? Do I need to do offload? Do I need to do encryption? How am I doing identity management? Am I federating? Where are all these different controls that we need to look at in it? And it's all about layering, but not layering to the nth level, right? What's appropriate? We don't want to do more security than is necessary, but we don't want to do less. There's a balance there. Right? If we make it too hard, people won't use it, or whatnot. In terms of, if you think about a secure infrastructure, secure architecture, there's lots of toys, lots of building blocks to do. These are just not an exhaustive list, right? So to do that, what are all the things, right? And you think about, it's all about people, process, and technology. You probably hear that ad nauseum, but it's true. It's about people, process, and technology. Unfortunately, what happens is, in my view, everything on the left there in the big oval, that's all the sexy stuff. That's all the bright, shiny objects where they go, yeah, I'm thinking this is my water, I don't know. So we better not drink either of them. I'm gonna pick it up, like, yeah, this is cool. This is the latest new technology gizmo, and I can touch it. Therefore, I can configure it. It has some standards. I can do something with it. It's sexy, it's bright, shiny. It's attracting my vision. When you talk about policies, process, test cases, how many test engineers, quality control folks in here? How many former test engineers in quality? No one. How many people have had to write test cases? All right, is that fun? Do you like, man, I gotta go write 50 test cases today? Well, actually, that's funner than actually doing the test, okay? Because you're like, okay, I'm gonna write this, because that requires creativity. But the stuff on the right, that's the really non-sexy stuff no one likes to do. What do? I'm writing the process guidelines for information security architecture. What do? I'm installing FireWire across the enterprise and we're stamping out malware. Now, what sounds more exciting? No-brainer, right? Okay, but the reality is, we can do all the bright, shiny objects all we want. That's the cool stuff. We can layer it. That's the two paths. That's well-secured infrastructure and crappy code, okay? Because all you're focused on the bright, shiny stuff and you don't have any controls around what's making it run. Anyone deal with any serious Vendor security issues, I guess including Cisco. We all have ours, right? Anyone? We're just like ad nauseum. All big vendors have major security flaws. Oracle, Cisco, Yahoo, Google, Adobe, Juniper, right? There's issues. Some of it's third-party products. Some of it's lack of a secure development lifecycle process. Some of it's lack of knowledge. We all have to be informed about what it takes to do a good job from a security architecture perspective. I'm watching time flash me or something when I have to go. So a few golden rules about building it in, something to think about. Better than writing and doing test cases, okay? Right? How many people are on the implementation teams? Anyone? A few of you. Okay, don't be shy. Implementation can be cool, okay? That's what, when we grow up and we can no longer code, we join the implementation team, okay? All right. We got to follow established PLC. No more cowboys, whatever. When I first joined Cisco, again, some of you probably weren't born, but no, I'm sure there's, at least everybody's got to be in their 20s. But you never know. Kids are starting young these days. I started at 19. My first technical job programming at 19. You know, you got to follow the SDLC, PLC, whatever it is. You got to validate input data. Okay, how many honestly say that you're writing code, you validate your input data? You're honest, I like that, thank you. How many after tonight you're going to go back and saying, well, could I have done a better job in validating my input data? Oh man, okay. Good thing the camera's looking at me and not at you. All right? But you never know. There could be cameras abound in here, people with their iPhones, you know, the YouTube temptation, right? I like having the things up there. So it's all about the data. Think about what kind of data they're using. It's got to be secured in motion and at rest. And use authentication. Are they doing strong authentication? Really, for some of you smart folks out there, I'm sure there's a lot of smart chicks and dudes in here, really help us out with stamping out clear text passwords, okay? They're boring. Cisco 123, welcome 1 through 3, test me. And the longer ones are too hard to remember. So there's got to be something better, right? On the iPhone, here's a new app, Android, whatever. You know, I want to do this. Don't worry, I'm not going to malware. No, I'm not. We talked about this at the offsite. Identify me. Okay, I can log on. Now, is that easy? How many people would do that? Y'all need to get with the program. All right, move on. Yes. Your group can have a coding session, and you could probably do that in under 3 hours, okay? That would be a Sensation app. Identify me app. Of course, there's a lot of security implications. Now, what if the biometric footprint is stolen? How are you going to secure that on the mobile device? How are you going to transmit it? How are you going to do the initial, is this really you when I'm doing my palm and then it's not Kevin or the lady next to him, are you over here, right? Okay, well what if I already took a picture of your palm and you're holding it? So there's a lot of things around there, but that would be a totally super cool app if we could do it securely. If we could 100% guarantee that that application was secure and validated and in the totally trusted app store, how many people would use it? Okay, change is hard, I know. We would have to bring in the adoption manager and the whole communication and awareness to get you all on board. But eventually, I think you would be converted, right? Just an idea. If anyone could develop that app securely, you'd be making a lot of money, or something better than clear text passwords. You've probably read the rest of this, but anyway, I'll go over some of it. Right? Think about, where's the traffic crossing? Do we need to validate it? We're coming in a world that we can no longer secure the endpoints. It's all about the data. How do I tag the data as it crosses the network? So it knows when it passes a boundary device, this data is highly confidential. The gates go up, it's not leaving. Right? Or this data is engineering code only, you can only go over the NIST network, right? At Cisco, that security group tagging, but there's other things. How well is it really going to work? Can we tag the data as it goes across the network and do controls that way? At the minimum, we have to understand if you're, I mean, almost everyone's writing applications and stuff that deal with data, otherwise, what are you writing? It's all some kind of data, right? It needs to be secure, it's about the data. The infrastructure, how many people are like infrastructure support? You rack and stack, you configure, you test. Any hardware people? I like this lady back there. She does it all. You rock, okay? All right. At least she's honest. She's raising her hand. I don't know. I always said I'm raising my hand. I used to do infrastructure. Actually, the funnest, the most daring things I did at NASA Ames, little story here, I was thinking about these. You know when you're young, some of you are still young, you can do anything. Probably a lot of you, or most of you don't remember the Sun 1s, multi-plane backplanes. No, it's multi-bus backplanes, that's okay. But anyway, I worked for a lab, the human factors lab, and they wanted to upgrade our Sun equipment and this is before NFS too, by the way. They wanted to do all this new stuff, but our boxes, you know, the 100 megabytes is about this big, right? I'm like, I can do that. I ordered all the hardware, I pulled out the schematics, I tore apart the equipment, put on the new backplane, put on all this kind of stuff, redid the operating system. I was probably like 22 years old. I can do it. You got to take those kind of challenges and reach out. Amazingly, it actually all worked when I got done. Didn't think anything about security because it wasn't on the map. But you know, hey, you got infrastructure's about it, right? These are just some example. How many of you work in your engineering departments where you have a PLC process, something that vaguely looks like a PLC process that you follow? Oh man, okay, where do you work? I'm going to deinstall all the applications. I'm not going to use your software. And you better not be raising your hand if you're at Cisco because we have the CSDL process. Ask, maybe you don't know. That's part of it. We've seen that the engineering teams, the implementation teams don't know there's actually a process they're supposed to follow, right? Step one, perform the gap analysis. What is the attack surface of what it is you're trying to build, right? Just an example, you don't have to look at all this stuff. So some questions to ask, and I'm wrapping up because I'm sure I'm supposed to be off here pretty soon. Think about the data. You're writing a snippet. It could be, you know, I could probably still write hello world, but it'd have to be in C. I'm not even sure if they use C anymore, right? I saw the Java, but I could probably handle that one. I mean, anyone here programming COBOL, Fortran, PL1, Logo, Lisp, Pascal? Okay, I've done all those, but a long time ago. Think about the data. What is the highest sensitivity of that data? How can it be used? How do you have to protect the data? How are you going to do authorization, authentication? Don't roll your own. There's probably some sort of standard. Don't roll your own for encryption. There's probably some sort of standard, right? What are all the communication channels? What are you connecting to? It's not just your stuff. It might be some third-party stuff. Maybe you're in front, so I'm sorry, Kevin, and I can see your name because I don't have my glasses. And Rupa, Kevin, you're writing a kick-butt application. I don't want to say Rupa because I know she writes good code. And someone else that's not even here, you're going to connect to. You want them to write good code, right? Yeah, so you need to think about what they're doing and talk to them. There's a communication channel there. Right? What is the end solution? Is it going to be some sort of service provider, X as a service? How am I interconnecting? What are the parts? Think about the big picture. Don't be so, I'm writing my code snippet, it's going to be kick butt and secure. What is it connecting to? What is the big picture? Right? What are the laws? Okay, this is boring. What are the regulatory laws that apply? You probably don't know. Therefore, you want to ask someone in your organization that knows. What is the extra stuff I need to do? If you're writing, how many database folks here? Wow. That's okay. I'm not a database person either, but I had to work at HRT for 4 years, and I could barely spell database when I went over there, and I had to learn far more than I ever wanted to. Right? So how do you need to do the constructs in the database and secure it at the table, row, whatever structure level? Right? What are the misuse cases? Anyone here think about the misuse cases? All right, cool, thank you. Miss Kickbutt back there, lady in the dead center. You rock, you gotta rock. You gotta think about the misuse cases because that's whatever the intruders are thinking about. Don't go, well, no one will ever try that. They're not gonna try that combination. They're not gonna click there and here at the same time. They're not gonna add those characters on the end. They would never try to shove 250 characters in a 10 character buffer. You got to think about the misuse cases, and it depends on what vertical you're in. They're going to be different, whether it's finance, whether it's aerospace, whether it's engineering, whether it's mobile. It's different misuse cases, but always think about the misuse cases. Those are actually more interesting, really. More exciting to think about. Lastly, you can make a difference, even if you can't hardly spell security. Okay, after tonight, hopefully you can. Hopefully you're a fan. There's some people here who said they live and breathe and think security. Anyone more inspired about it? You're like, I don't know who that chick is, but she's like really weird. She's definitely a newbie, right? Okay, you need to think architecturally about security. What is the big picture? What are you connecting on? What can you do as your part? You need to ask some of those key questions that I had back there on that page. And actually, one of my industry things we're kind of working on is for each of the verticals, manufacturing, HR, finance, all the different spaces, what are the key questions that pertain to that particular area that I need to ask about? There's general ones and there's vertical specific ones. What are the design patterns? Right, I'm sure you guys think about design patterns you reuse or you just go like reinvent every time. It's really cool when you can borrow what someone else has done that's a standard, right? What are those design patterns that's been solved for those complex problems before so I don't have to reinvent? What is the attack surface? That means where are the input channels? Where's the data? How's it being stored? What's the authorization? Is it internally facing? Is it externally facing? That's all goes into the attack surface. When you understand the attack surface, your job is to minimize and make that attack surface small as possible. Hopefully zero, but that's really hard to do. Fail gracefully, right? I'm sure you all think about failing gracefully, right? What's a good graceful fail? Follow product security baselines, but I think I asked that questions and people didn't know about it, right? You gotta have product security baselines. I'm not gonna ask that question. We do at Cisco. Ensure that you actually, if you're handed a design document, you actually code the standards and don't kind of, well, we didn't know how to get it from the blob automatically over here, so we kind of did the third step with we knew how to do the FTP really good, so we did that. No, that doesn't count. Grow your security knowledge. Think about everything that you touch on a daily basis, if not for your organization, for your personal self, your household. Think about, you may own a smart car. Many of you probably already have smart TVs. You definitely have smartphones and smart tablets. Almost everything you can do all day long should be suspect. Actually, don't have a Twitter account because there's so much that happens on it. Every link in Facebook could be suspect. Google searches can have iframe injections, but it's one of those things you can't be super paranoid. Like, oh my God, I don't want to get the flu, I'm not going to touch the doorknobs, the table, I'm not going to shake hands with you, right? So we do security precautions, we wash our hands. The same thing with security. You got to think about it and think about what can happen. And lastly, be an evangelist in your area. If you're a developer, go back to your organization and say, do we actually have a secure development lifecycle? Do we have product security baselines? Do we have a secure coding guideline that we need to follow? Is there any training that my organization provides that I can do to do my part? What are the misuse cases? Talk to your peers, grassroots, get the information out there, right? So a call to action for all of you. Are you willing to do your part? Are you willing to be proactive about security? Can you take action where you see a potential security issue? Can you make the stand? Sometimes that takes boldness. I'm just known at Cisco for calling the pink elephant out in the room. Just like, hey, I've been there long enough, I have a big enough title, right? Even today on the call, I made a statement, and then it was like silence. It was a WebEx call, so I couldn't see anyone's faces, and they couldn't see mine, but it was like silence. I'm like, and there was silence on the table. And they're like, you're right. Meaning, what I said, they were right on, spot on. Can you take a proactive when you see an issue? Can you do your part in making sure built-in is attainable? If any of you touch code in any way, whether you're writing it, whether you're writing the design guide for it, whether you're writing the product specification, the business requirements document, the functional specification, the test cases, or the exit criteria, you impact the overall security of something someone's going to use. You need to do your part in making it obtainable. And at the very least, if you think there's something there and you're not sure, throw out the red flag on the field that says, go back and get someone else who has more knowledge than you. And just be honest about it and share, right? Because we got to do our parts in making it secure and attainable. Recap. Architecture means different things to different people, right? There's nothing magical about it. It's heavy lifting. It requires thinking on big pictures, but there's themes, there's design patterns, right? There's secure coding standards. The practice of information security architecture needs to be repeatable and easier to do so people do it. The knowledge, there needs to be standardization, sharing so we can spread the knowledge. Engagement as process, and last of all, let's work on it, doing it together to build a consensus. Thank you.